Brittany? Brittany? Are you there, Brittany?
Yes, I'm here. Sorry, I'm using my phone tonight. My internet's still having
No,
problems.
I'm sorry. Did you didn't withdraw, did you?
No.
Okay, it was somebody else. Yeah, I thought that the person that was withdrawing, it's person had something happen to them, and so I thought it was on Thursday, but somehow your name just popped up there. So never mind.
Okay.
How we doing, guys? We doing okay?
Great.
Yes, sounds on with all the enthusiasm of a class that begins at 7 o'clock, right? Well, and the good news, I already ate, so I'm in good shape, guys. I just want to see something. Have you been getting the PowerPoints, or haven't cared? They're available to you?
Where are they at?
Did you post last week's PowerPoint?
At this point, I don't know. Maybe not. That's why I'm asking.
I didn't see last week's.
Yeah, I
The rest
saw
are-
some of yours just like this, but yeah, this is what I saw is exactly what's on your screen.
Okay. Well, I apologize for that. I can fix that real easy. Nope, I need this. Okay. My computer, upload. Documents, where are we at? You know, it's going to be great in 3 years. I can throw all this crap out. What is it? Yeah, I need this. I need that. I need this. I apologize for that, ladies and gentlemen. That one's in there. And now I will put this week's in there as well. Okay. Oh, crap. I promised to put it in. Okay. I promised to put it in. I can't put it in right now because I haven't uploaded. Okay. Victoria's in. Anybody have any questions? Last week, was that pretty straightforward, that lab? Kara's saying yes.
Yes.
I had an issue, but I sent you an email about it.
Did I answer?
You did, but you told me to go to the PowerPoint, and as we could see, it wasn't there.
Sorry, Brittany, call me. If something like that happens, that would have gotten the PowerPoint up right away. And
I tried YouTubing it. I just couldn't figure out how to get it right. And so I just know that I didn't do too well on that results.
What was it you had? What issues you have?
So the lab obviously has the I guess the equation example. I mean, there's no actual example, it just has like the formula for it. And I just wasn't sure if I was doing it right. And then by the time I sent it, I was able to contact the tutor, and I found out I was doing it wrong the whole time anyways. So
Can you do it right now?
I sent you the email of me redoing some of it just to see if I was doing it right even after the tutor. So I don't know if the email, you didn't really respond back saying if I was doing it right or not.
Okay, I will make sure that I get that. I will look at that email, okay?
Okay.
Sometimes what happens is I get involved in doing things and then I get, no, it's not what I want. Actually, I do want that. Okay. Get it done by Thursday?
Oh, absolutely. I just want to make sure I'm doing it right.
Okay.
Well, I guess the PowerPoint's up now. I can go look at it.
Okay. So everybody now has 2 attempts on it. Okay, fair enough, guys? Fair enough?
Sure
Yes.
thing.
Because I didn't respond in a timely manner, I'll just go ahead and give you a second chance.
Did you ever get a chance to upload last week's recording?
Last
Oh.
week's recording should be there.
I didn't see it last night.
Yeah, I'm falling down on everything, aren't I? Zoom meetings.
Yeah, I had to watch like your other classes recording.
Guess you're right. I am just falling down on everything. I'm so sorry. Another
Okay.
reason why. Okay, I will get that uploaded. Upload. The upload recording. Okay. All right,
Thank you.
now, Brittany, what was the problem you were having? Brittany?
Sorry, it's really hard to do this on my phone. Oh, how did I do it? My lab book is inside.
Can I show your thing?
I would,
Do
sure.
you mind,
I
do you
mean,
mind if I show your submission?
it's gonna be wrong, but sure.
Okay. All right.
It was the first half of it I could get is the moles that I was having problems with.
Okay, all you have to do, Brittany, I think I did answer you.
You
What
did, but
Brittany,
the-
what you did was you divided by the molecular weight twice. I couldn't figure out why you were doing that.
me neither, apparently.
You only have to divide by it once. Let me go, let me do something else. Okay.
That's me just asking for the Zoom.
Last night?
No, that was me. That was me just now saying, hey, where's the Zoom at?
Okay.
But it was, if you scroll down on it, it was a response to my email prior.
Stop it. Okay. By the way, guys, this is not going to take us that long tonight. Okay, Brittany,
Go ahead.
do you see you're having moles of water, mass of water times 1 mole of water over 18.02. That doesn't equal grams. That equals moles.
I put moles. I was dividing, I think, the wrong thing.
No. Right here, you're taking the math. Do you see the letter the email that's up?
No.
Okay. Stop share. Share screen. Hopefully I can get the email up. Are you seeing the email now?
Yes.
Okay. Do you see where my arrow's at?
Yes.
All right. What you're doing is you're taking moles of water is equal to mass of water times 1 mole of water over 18.016 grams of water. Grams cancels and you're left with moles of water. But you called it grams again, and then you multiplied it by 1 over 18.06 again. You only have to do that once.
No. That was the verbal description leading into the number, how you asked to have it on your results. It's pretty much the same thing.
No, it's not, because you've divided. Look, you took the 0.272 and you divided it by 18.016 again. Look at the numbers. That's what you did.
I think you're misunderstanding me.
Okay. Give it.
The first half of that is just me saying what I'm about to do. The second half is me actually plugging in the numbers.
Ah.
And I that 0.272 was the mass of water.
I got you now. I'm sorry. Okay, so you're doing that when you this is the problem with email. This what I'm interpreting is that you did it twice. Okay, now we got that straightened out. So that's how you get moles. Okay. You
Now, is
also
that
you
correct,
also
or-
should have gotten moles or grams of copper. Okay,
these Yeah, these are just two examples that I was sending you saying, is this the correct math? Am I doing it right? Because what I sent you in my results was not these answers. I sent
Okay.
something.
Okay, these are correct. As they sit right now, they are correct. You also needed to get the moles of copper, which is
Okay, yeah,
grams of copper times 1 mole over 63.5, I believe.
yeah. Okay, yeah, that math was done after I talked to a tutor, which was after I sent my results in.
Okay, I'm sorry that my response to you doesn't make any sense.
No, it's okay. I just appreciate you allowing me to redo it.
6 figs, sig figs. 3
What are you saying?
sig figs down here. 3 sig figs. This should be 3 sig figs. 3 sig figs. This should be 3 sig figs.
So what am I missing?
You took your weight was 3 significant figures.
Yes.
You multiplied it by a number, 1 over something with 5 sig figs, or in other words, you divided it by the 18.016. You had 3 sig figs, you divided it by something with 5 sig figs, and you ended up with something with 2 sig figs.
Okay, so just one more number.
Yes.
Okay.
And 2 more numbers in the case of chlorine.
Okay.
Okay. Anything else, ladies and gentlemen? Anything else on what we did last week? Questions on that? I've reopened it. It's opened until, I believe, Thursday at 5. So you have until then. I've also given you another attempt. This is on me for not providing you with the recording or the PowerPoint, which won't happen next week. Okay? Also, if somebody notices that, guys, if you notice I don't have something recorded, please let me know. Okay? Let me know as soon as possible so I can get it up for everybody. Nobody has anything else? Okay, Carol, you're the one I can see. I can see you shaking your head. So we're going to go just because Carol said so. Are you seeing the PowerPoint?
Yes.
All right. These are fairly easy. These are fairly easy calculations. All right, fairly easy calculations. All we're doing is stoichiometry. And the stoichiometry we're doing is based upon the fact we're monitoring a reaction until it changes color. When it changes color, that means I know that my H pluses are equal to my OH minuses. You got to accept that. There are 2 things you have to accept in this laboratory. When it turns pink, H pluses are equal to moles of H plus are equal to moles of OH minus. And when it's pink, it's neutral. Those are the 2 things you have to accept from this laboratory. Now, let's go back and talk about moles. You guys have a lot of weapons. You have a lot of weapons in your belt that I'm not even sure you're aware of. You guys can get moles by dividing grams by the molar mass, which is what you did last week. If I have 24.2 grams of sodium chloride, I can get moles of sodium chloride by multiplying it by 1 mole over the molecular weight of sodium chloride to get me 0.414 moles of sodium chloride. If I have a volume of a gas that's at STP, I can get the moles by dividing the liters by the molar volume. In other words, if I have 34.6 liters of argon at STP, I multiply that by 1 mole over 22.414 liters. I get 1.53 moles of argon. If I have a concentration and a volume, all I have to do to get moles is turn the volume into liters and then multiply the liters by the moles per liter, which is the concentration. So if I have 3.5 molar HCl, and I happen to have 350 milliliters of it, I just changed the label of moles of molarity to moles in 1 liter, and I multiply it by the number of liters I have, I get the moles of HCl. It doesn't matter how you get the moles. You can go by any path you choose. Moles are moles. It doesn't matter whether you got them by multiplying the concentration by the volume, by determining the volume at STP and getting the moles that way, or by taking the weight and dividing it by the molecular weight. They are all moles. They can all be treated the same. All right, another thing I got to teach you how to do, and that is reading a buret. Now, when you read a buret, if you can look at this, you can see the numbers are getting larger as you go down. So you read a buret from the top down. In other words, this is 40 point something, not 41.9 something. Do we understand that? Burets are meant to read from the top down. And the reason we do this is burets are meant to show how much volume is delivered. So we record a volume initially. We add the liquid to something else and we stop it. We read the final volume. The volume delivered is the final volume minus the initial volume. The other thing about burets, absolutely, guys, I'm sure there are burets out there that are better than this, but 95% of the burets out there, the smallest line is worth 1/10 of a milliliter. Therefore, you have to estimate to 0.01 milliliters. So if I am looking at this, I'm beyond the 40.0 line and I'm about halfway to the 40.1 line. So I am going to read this meniscus as being at 40.05. If your estimates do not go out to the 100th of a milliliter, I am going to severely take points away because I've taken the time and effort to specifically tell you. Burets you read to the 100th of a milliliter. Questions on this? Okay, the two assumptions we're making. When it's pink, it's neutral, and when it's neutral, moles of H plus equal moles of OH minus. Phenolphthalein is an indicator. What an indicator does is it basically causes a reaction to occur, and when a reaction occurs with the indicator solution, it occurs at a very specific pH. So you get to the right pH, the indicator changes color, and you know you are at the end point. Phenolphthalein is bright fuchsia when it's basic. It's clear when it's acidic. So when you have a color that is very slightly pink, you've got a neutral solution. And when it's neutral, moles of H plus equal moles of OH minus. You notice, guys, I did not say moles of acid equal moles of base. I said moles of H plus equal moles of OH minus. Let's give you a scenario. If I have sodium hydroxide reacting with HCl, I make sodium chloride and water. The coefficients in front of the sodium hydroxide and the HCl are both 1. So in this particular instance, when I have NaOH and HCl, the moles of the H plus are going to equal moles of OH minus at neutrality. And subsequently, because my coefficients are 1 to 1, my moles of NaOH equal moles of HCl. In this case, I can use a shortened version of the formula. If I know what my molarity of my acid is and the volume of the acid, that's, if I multiply those two things, I will get the moles of the acid. And at equilibrium, at neutrality, moles of acid equal moles of base, which is going to be the concentration of the base times the volume of the base. I can shorten this whole equation out to be molarity of the acid times the volume of the acid is equal to molarity of the base times the volume of the base. Is this making sense to you? We got it? Shake your head, Kara. Tim, you got it? All right. What happens when the number of H pluses delivered by the acid do not equal the number of OH minuses delivered by the base? I have sulfuric acid. I have 2 titratable hydrogens. I have 2 acidic hydrogens in H2SO4. But I have only 1 OH for the KOH. What this means to you is my moles are not equal. My moles of H2SO4 are not going to equal my moles of KOH. In this case, we have to use stoichiometry. If my acid were 1.20 molar times, if I used 45.50 milliliters, I could change the milliliters into 0.04550 liters, multiply that by my molarity, and I get 0.0546 moles of sulfuric acid. But that sulfuric acid, I need 2 moles of KOH for every 1 mole of H2SO4. So my 0.0546 moles of H2SO4 are equal to 0.1092 moles of KOH. If I know what my volume of KOH, then my concentration would be just taking the number of moles of KOH, dividing it by the volume, and I would get 3.58 molar solution of KOH. If the coefficients of the acid and the base are equal, then we can use MaVa equals MbVb. If they are not equal, we have to go through the stoichiometry. Questions, ladies and gentlemen? Basically, this is all titration chemistry. This is all what we're doing in titration chemistry. All right. What we're doing in this experiment, our acid is solid KHP. Ladies and gentlemen, this is not potassium, hydrogen, phosphorus? It is potassium hydrogen phthalate. So if you're using 39 plus 1 plus 31 to get your molecular weight, you will be wrong. KHP is potassium hydrogen phthalate. Its molar mass is 204.22. So what you're going to do, this is a standard acid. You're going to weigh out between 0.2 and 0.3 grams of the KHP exactly in an Erlenmeyer. And you're going to dissolve it in about 50 milliliters of water. You notice I said about. I don't care how much water's there. I'm not determining moles at this point by concentration. So because of that, I don't need to know how much volume I have in there. I could put 100 milliliters. I could put 1,000 milliliters in there. It would not affect my experiment. So I am going to determine the moles of my acid by taking my grams and multiplying it by 1 mole over the molar mass of 204.22. I'm then going to add the milliliters of water. Next step, when you're doing the procedure, you condition your columns. If you rinse out the burets with water, and you put the sodium hydroxide in there on top of this water, haven't you diluted that sodium hydroxide? If you've diluted it, it's no longer the same concentration as from the bottle you have. So what you have to do is you have to condition your burets. You have to take your standard sodium hydroxide, pour it in the buret, get about 5 milliliters in there, drain it, do it again, put about 5 more milliliters, drain it again, put it in a third time. What you are doing is you are acclimating that buret to the concentration of sodium hydroxide in your bottle. You're going to fill the buret with the solution above your 0.00 milliliter line. Then you're going to open the buret. You need to make sure there are no air bubbles throughout the entire buret. You need to let the volume go to 0.00 or below. If it is not below the 0.00 line, you cannot determine a volume. At that point, note the initial volume of your base. You're going to add 1 drop of phenolphthalein to your KHP in water. You're going to swirl it around. You're going to put the flask beneath the buret, and you're going to carefully add NaOH until the solution just turns pink. Then you're going to note the final volume of your base. That's the whole procedure. That is the whole lab that we have to do. Remember, when we said it's pink, it's neutral. H pluses equal OH minuses. KHP delivers 1 H plus. NaOH delivers 1 OH, so the stoichiometry between the two is 1 to 1. If I measured out 0.253 grams of KHP, multiplied it by 1 mole over the molecular weight, this means I have 0.00124 moles of KHP. I multiplied this by my stoichiometry. That means I have 0.00124 moles of sodium hydroxide. Now, if I noted the initial volume as being 0.05 milliliters, and I opened up, I added sodium hydroxide, it turned pink. I stopped it off, I looked at the final volume. It was 10.15 milliliters. I can tell how much volume that buret delivered by subtracting the initial volume from the final volume. I do that math out, and I get 10.15 minus 0.05 milliliters. This gives me 10.10 milliliters. If I had 0.00124 moles of NaOH, which I know I did because I'm at neutrality, and that's how many moles of KHP I originally had. So I'm going to take the 0.00124 moles of NaOH and divide it by 0.01010 liters. I'm sorry, divide it by 0.01010 liters. I do that final math, and I get a concentration of 0.123. This is the molarity of my base. He's pausing for a minute to let it sink in. Are the calculations difficult, ladies and gentlemen? All you're doing, you're going to be given the data for this. All you're doing is taking the weight of KHP, dividing it by the molecular weight of KHP to get the moles of KHP. You will be told how many milliliters it took to turn the solution pink. When the solution is pink, moles of KHP equal moles of NaOH because the stoichiometry is 1:1. Then all you do is take the moles of NaOH, divide that by the volume in liters, you have your molarity. If you get a number, it's not around 0.1, check your math. Make sure that you've done all the math correct. Now, Brian.
Yes.
Have we done anything to change the concentration of the base as
No.
it is in the buret?
No.
So, if you do a second trial, should that second trial be the same as the first?
Yes.
How about a third trial? Should that one be the same as the first two?
Yes.
Fourth, every time you do this, it should be the same, right?
Right.
So what you're going to have to do is you're going to have to tell me how precise the readings were that are given to you. The way you do this is calculating a number called standard deviation from average. What you are going to do is you are going to take all of your trials and average them. The standard deviation is going to be the absolute value of your trial 1 minus the average, plus the absolute value of your trial 2 minus the average, plus absolute value of trial 3 minus the average. You're going to keep on doing this until you get to the nth trial. And that will be trial n minus the average absolute value. You're going to add all these numbers up, and you're going to divide it by the number of trials. And that will be the number that is your standard deviation. It is an indication of how precise you were able to measure your value. If you get a standard deviation of 0, either you're awful damn good, or what's happened is you haven't done the absolute value. Is there anybody that does not understand absolute value? Okay. I did 5 trials. These are my results. Okay. I added all 5 up, divided them by 5, and I got an average of 0.1151. To get my standard deviation, I took my first trial value, subtracted 0.1151. Got the absolute value of that. To that, I took my second trial, subtracted the average, absolute value, third trial, fourth trial, fifth trial. I got the absolute value of all my trials minus the average. I added those differences up and divided by 5, and I came up with my standard deviation. Looky here. This number should be negative, but since I took the absolute value, it is a positive number. Same thing with this value. That one should also be negative. So, what does standard deviation mean? It means that you have a range. Standard deviation can be plus or minus your average value. So if you have a standard deviation of 0.0004, this means that your range of your answer is plus or minus 0.004 of the average. That means that your answer is somewhere between 0.1147 and 0.1155. Questions on this? Okay. Apparently, this is where I get fed up with bad notebooks being submitted last semester. So this is where I redid the notebook thing. If you want it, it is there. If you want the if you want to have a reiteration of what I want in the notebook, it's here afterwards. Other than that, ladies and gentlemen, I'm basically done. I will go through and I will go through the results section. Again, you are finding your data. Student data for labs, guys. That's where you're finding the data for this. Just to pull that up for a second. That is it. You're only doing 3 trials. Now, you may have remembered that I said something way back. When you're doing multiple trials where you're supposed to get the same answer, you only have to give me 1 calculation. You're going to have to do them anyway. You might as well do them in the calculation section. But if you don't want to, you don't have to. All I want to do is see 1 calculation in in the notebook section of calculations. So that's where our student data is. Come on, thank you. Let's go through the all right. Results section. Preview. Are you seeing this, guys? Thank you. Start quiz. This should be fairly easy and fairly straightforward. Okay. Question A1. How many moles of KHP? Just take the grams, multiply it by 1 mole over 204.22. You've got it. Do not worry about part B. You did not use anything, so don't answer part B. You don't have to. Part C, total moles of H plus. You are just going to give me the moles from the KHP. Are we good with that, guys? So you're answering A and B. You are not answering A and C. You're not answering B. Second question. How many moles of NaOH were required to titrate the KHP? Same number of moles that KHP we had. What is the molarity of the NaOH? What you're going to do there is you're going to take the moles divided by the volume in liters. That will give you the molarity. Average. Yeah, I want to see what your three values are. I want you to do this calculation. I want to see all three values, the fact you divided by 3, and then give me the average number for that. So I do want to see that. And ladies and gentlemen, that's it. Easy peasy. Nothing to it, right, Kara?
Sure.
All right. I'm going to exit preview. Now we're going to get into the post lab. I'm going to see if there's anything hidden there for you. Preview. Start quiz. And my guess is these are going to be a whole lot of titration questions. First question. If you added extra water, I told you it didn't matter. If you added extra water, would it change your calculated molarity of NaOH? One of these answers is correct. All right, now, this is something he never talks about. If you had an air bubble, prior to starting the titration, would it affect the concentration? Let's talk about this. You have an air bubble. You had a whole blank. All right, say your initial volume was 1. You had a 1 milliliter air bubble and you stopped the titration at 5. How many milliliters did it actually take to do your titration? You started at 1, you had a 1 milliliter air bubble, and you ended at 5.
So 3.
3. That's how many it actually took. But if you didn't notice that 1 milliliter air bubble, you would have thought it took you from 1 to 5, and your answer would have been 4. Does that make sense? That's what that question is asking you. Is that going to affect your results?
Yes.
Think about why. All right. Now it's giving you a problem. If you have, it's a problem just like we did in the lab itself. It's giving you a number of grams of KHP. Different thing. Sorry, I'm glad I looked at this. Sorry, I have to take some notes down here. 26.85. All right. First of all, let's look at this. What is KHP? Is it an acid or a base?
Acid.
What about HCl?
Acid.
Okay, so what things are contributing H plus?
The NaOH.
NaOH is contributing H plus?
Mm,
What is contributing H plus? Do acids contribute H plus or do bases?
Acids.
Okay, and you just got done telling me that KHP and HCl are both acids. So
KHP.
what is contributing in this solution? Question 3. What is contributing to the total H plus concentration?
Would it be 0.4 KHP?
I don't want a number. I don't want a number.
Is it the HCl?
Partially. What else is contributing H plus?
Other than the KHP or the ionic bonding?
I know. Other than the KHP, now, Kara, yes, you're absolutely right. The HCl and the KHP are contributing H plus, right? So both the KHP moles and the HCl moles have to equal the NaOH moles at that point. Does that make sense to you guys? A scenario happens. You've got your titration. And how many times did you haven't done the lab. Has anybody done a titration yet? Okay,
Not for a few years.
Trust me on this. When you first do titrations, you're going to be very, very careful. And then all of a sudden you're going to go boop, and you're going to put a whole bunch of NaOH, and it's going to bright fuchsia. You can bring it back to clear again by adding HCl. So you bring it back clear again, and then you add more NaOH to get it pink. That's the reason we're adding HCl in here. We've over titrated and we're adding HCl to bring it back to clear again. But when we do that, we have to understand that our total H plus is now the moles of the KHP plus the moles of the HCl. So when I am doing this particular equation, I'm going to fudge things for you. Nah. And we're going to go. Okay. Now I'm going to stop this and I'm going to go back to the PowerPoint because I need to show you what's happening. Stop that. Stop that. You go over there. Thank you. All right. Ah, crap. I hate when this does this. Anybody know why this does this? Hmm. Okay. Moles of H plus. We said was equal to what? Talk to me, guys. This is to see if you were paying attention.
1.
No.
HP.
Are you
plus
talking about
HCl.
HCl and KHP?
Oh. Is that a true statement? Right? Is that a true statement, guys?
Yes.
Okay, so I get my moles of KHP are going to be equal to my weight of KHP times 1 mole divided by 204 grams, which is equal to 0.250 times 1 over 204. Are we good with that, guys? This gives me 0.00123 moles of KHP. How about my moles of HCl? Somebody tell me how I'm going to get my moles of HCl.
Mass of the HCl divided by the molecular weight.
There is no mass of HCl.
Is it by STP?
Not STP. What measurements do I have of the HCl?
Molarity and milliliters?
Okay, I don't trust myself when I get crap. All right. Okay. Now, how many moles of NaOH do I have?
Do you divide 0.0133 over 3250?
That's not the moles of NaOH. That is the molarity of the NaOH. Nice guess, Brian. So how do I get the moles of NaOH? It's at neutrality, right? We're at neutrality. It's pink, right?
Yeah.
Now, Brian, what do?
Divided by the milliliters.
Changed into liters.
Change into point. Yeah. 0.32.
Okay. The only difference there is that we added a second source of H+. So we had to figure out what the moles of KHP were, add them to the moles of the HCl. The combined HCl and KHP moles are going to be equal to the moles of the NaOH. You then simply have to take the moles of the NaOH, divide it by the volume of the NaOH. I know you're going to forget it. That's why I'm telling it to you right now. You will see a problem like this again. It will come up in a very strenuous time of your life. Nudge, nudge, wink, wink. So learn how to do this problem. I'm going to stop this and I'm going to go back to, hopefully, the share screen. That's all the post lab, guys. I am very glad that I did this because I would not have seen those couple of pitfalls that you might have run into. Anybody have any questions about what we're doing here? Brittany, if you run into a problem like that again, are you going to call me?
Yes, I have your numbers in my planner.
Thank you very much. Ladies and gentlemen, again, you have until Thursday to resubmit your, is it
Results.
Wednesday? You
Today's-
you have until 5 o'clock tomorrow to resubmit your empirical formula lab, if you so desire. That's all I got, guys. Dog and pony show's over.
Are you able to stay after once everybody leaves? I can talk
Yes.
to you.
Yes, Brittany, I will. I've already eaten.
Thank you so much. Have a good night.
You have a good night too, Kara.
Have a good night.
Have a good night, guys. Mac, you're here for a reason. Mac. Mac, are you here for a reason? Other than the fact that you probably, I'll cure it in a second, Brittany. Just let me. I got to do something. Kara was here. Madison was here. Yeah. Uh-huh. Okay. Attendance is taken. Mac, are you here? Mac, I am now removing you. Mac? Okay. Brittany, what I'm going to do right now, and this is, I am going to, let's get out of this. Stop share. I'm pausing.